class. Today we're going to talk about 2-5 and we're going to compare and order real numbers. The learning intention is going to be able to compare real numbers, right? Compare one number to another number, and we're going to know we have got it, right? We know what we're doing when you can convert real numbers to decimals and then plot them correctly on a number line. Let's see what that looks like. So you can go ahead and read all this on your own, but what it really just says is when you are comparing real numbers, you need to have them all in the same form first so you can properly compare them. And what that means is turn them into decimals. So just do the math. So for cube root of 47, you would just take the cube root on your calculator. For pi, you would just use the approximation 3.14. And same thing for the square root of 11. You would just use your calculator and take the square root of 11. You would round all of these to probably like the nearest second decimal spot. So for pi, that would look like 3.14. And you would want to stop at that second decimal spot. That would be good enough for what we're trying to do in this unit. And as we said in the previous one, turn them all to decimals, and here they did that for us, right? So we have the cube root of 47 is 3.61. As I said before, that approximation of pi we're going to use is 3.14, and their approximation of the square root of 11 is 3.32. Now at this point, you're just going to use your inequality symbols, right? Your less than, your greater than, and your equal sign. And you're just going to use those to compare your numbers. Tell me which one is bigger than the other. All right, so here we just put those approximations on the number line. 3.14 will go between 3.1 and 3.2. The square root of 11 is close to 3.3, and the cube root of 47 was around 3.6, and that's all you got to do, right? Put them on the number line in their approximations. You don't have to be exact, you just have to be close, especially on Alex, right? You just got to get close enough. All right, so in this example, they're just asking us to compare the real numbers square root of 8 to 2 2/3. So for this, you'd want to convert them to decimals. The square root of 8 is, I believe, 2.8 something, and 2 2/3 would be about 2.6 repeating. Therefore, the square root of 8 would be greater than 2 2/3. And let's take a look at the next slide and see if we are correct. And so here we are. This is essentially what we just did on the last page, but in a nice, neat form. So pause it here if you want to copy down what we did. All right, now here we plotted them, right? 2 2/3 is 2.666 repeating. So that would be bigger than 2.6, but just under 2.7. That's why we put it a little over that halfway point. Now, the square root of 8 was 2.82, so that's slightly above 2.8, which is why we put it here. Once again, you don't have to be exact, you just got to be close enough. All right, here's a check problem for you. All I want you guys to do is convert these two numbers into decimal form and tell me which one is greater or if they are equal. Pause it here and try it on your own. All right, if you converted these both into decimals, you should have found that they are the exact same number and they are equal. They are equal. So let's see what that looks like on the number line. All right, so for part B here, I just want you to select the appropriate number line. Which one correctly shows that the square root of 25 over 2 and the square root of 6.25 are equal. So pause it here and tell me which one shows the correct plot. You should have correctly chosen B, because if these numbers are the same, then they should be plotted on the same spot, and B is the only one with one plot. So B is the correct choice. All right, so here we're asked to compare the negative cube root of 15 and negative pi to over 2. So if we convert these numbers, right, we take that cube root of 15 and make it negative, we are going to be at negative 2.47, and negative pi over 2 is going to be negative 1.52. And remember, with negative numbers, the bigger number is smaller. So negative 2.47 is less than negative 1.52. All right, so let's take a look at a cleaner version of what we just did on the next page, and you can take notes from that. So once again, here's just what we did, right? They converted each number to decimal form, and then they compared them, and when they compared them, this is important, they had them back in their original form, right? You do need to put them back in their original form when you are comparing or plotting them. Please make sure you note that. All right. So once again, here we just plotted our numbers in an approximate location on the number line. Remember, you just got to be pretty close, not exact. All right. All right. So once again, I want you to convert into decimals. I will give you a hint on this one, right? For negative square root of 5, you're just going to take the square root of 5 and make it negative, and that will be your decimal. For percentages, when you are converting percentages into decimals, you need to take the percentage, so negative 210, and divide it by 100. That will give you the decimal, all right? Try this problem on your own. Answers on the next page. So when you compare your decimals, you should find out that the negative square root of 5 is less than negative 210%. So once again, for part B, right, you should have your numbers already in decimal form. I want you to try to plot them in the appropriate position. Answers on the next slide. All right, here you see the correct plot is D. Your number line should look something like that. All right, so here we are going to order numbers from least to greatest. This is no longer just comparing two numbers. Now we are going to compare a bunch of numbers. So step one remains the same, convert to decimals, all right? So take the square root of 30. Let's see what that is. And that should equal 5.48. All right, then our next number is 6. We actually don't have to do anything that is just the number 6. Then we have 5 4/5. So to do that, to convert a mixed number into decimal, I recommend just putting your number, the mixed number part, in front. That'll be 5. Point, and the things that come after your decimal are just going to be the numbers you get from doing the division in your fraction. So 4 divided by 5 is 0.8. So 5 4/5 is 5.8. And once again, 5.36 is already a decimal. You don't have to do anything with that. So now we can order, all right? We have, this says, let's see, from least to greatest. So least is smallest, greatest is largest. So we are going from smallest to biggest. The smallest number we have here, if you look at our set they gave us, is 5.36. And that is going to be less than. The next biggest number we have is going to be 5.48, which was the square root of 30, which is less than. The next smallest number we have is 5.8, which was our mixed number, 5 4/5. And finally, our largest number is just going to be 6, which was just 6. So once again, the next slide should have everything we just did on this page, but nice and neat for you to read through and copy. So here's everything nice and pretty for you. Pause it, copy these notes. This is the work we did to solve the problem. So this is what the order we had put them in. But once again, this is just nice and neat so you can see what I did when I was using my pen, which, sometimes is a little hard to read. So that's why I include these slides so you can see it nice and neat. And finally, once again, this is just where we put our decimals on an approximate position on the number line. Remember, I don't expect you to know exactly where 5.36 repeating is, but I do expect you to be able to get close. All right, so on your own, I want you to convert all of these numbers into decimals. This one, 1.35 repeating, is already converted, so you just have to do the first 3. After you convert, tell me which one of these selections is correct in order from smallest to biggest, right? Least to greatest means smallest to biggest. So after converting and ordering them from smallest to biggest, you should have gotten A. The correct answer was A. Let's see what that looks like on a number line. So using the same decimals that you used when you were putting them in order from smallest to biggest, use those decimals to find the approximate location on the number line, and then tell me which choice you think is correct. All right, so once again, your correct answer choice should have been A. That is the correct approximate locations of your numbers on the number line. All right, so that is it for Unit 2. Please make sure you have all 4 of your practice assignments done. You can find the options you have for each assignment in your focus description of the assignment. All right, I feel like I just said assignment a million times, but you guys know what you need to do. Get it done before Wednesday. Your test is on Wednesday. Good luck.